Hello everyone, welcome back to Introduction to Data Science Part 3. In this chapter, we're gonna dive deeper into exploring data. So what is data exploration? Data exploration is a preliminary or initial look at the data to understand its characteristics. For the key motivation of this data exploration include helping to select the right tool for preprocessing or analysis, which means that when you explore your data, first we have to check the data types, ranks, missing values, and distribution, so you can decide the best way to clean and analyze it. Example, if you see a column with many missing values, you might choose to fill them by using min, mode, or can we remove that column. So in short, exploration helps you pick the right preprocessing tools and analysis method for your data. Also, making use of humans' ability to recognize patterns. Humans are very good at seeing patterns visually, often better than computers at this early stage. In short, humans can use intuition and pattern recognition to find meaningful insights and can reveal hidden issues or rare patterns that automated process overlook. For the next page is techniques used in data exploration. In EDA, as originally defined by Tukey, the main idea was focus on visualization. Also, clustering and anomaly detection were viewed as exploratory techniques, which clustering it helps you to discover groups or patterns naturally present in the data, and anomaly detection it helps you to find unusual data points that might indicate errors or special cases. In data mining, clustering and anomaly detection are also major areas of interest and not true of just exploratory. So in this data exploration, we will focus on summarize statistics, visualization, and online analytical preprocessing. The next page is about illustrates exploratory data techniques using the arrays plan dataset. So this plant, it has three types of flower, such as Cytosa, Virginica, and versicolor. There are also four attributes, which are sepal width, sepal length, petal width, and petal length. In these summarized statistics are numbers that describe key characteristics of a data that they give you a quick overview. We are looking at all of the data. Summarized properties also include frequencies, location, and spread. Example, location we have mean, and spread also have standard deviation, also have rank or variance. Most summarized statistics can be calculated in a single pass through the data. Furthermore is frequency and mode. Frequency is the percentage of a time in a particular attribute value occur in the dataset. Example, if the attribute is gender and the population is people, so the female gender might represent about 50% of the observation. And next is about the mood. The mood is the most frequent attribute value in the data, which means that the value that occurs most often. So next is percentiles. What is percentile? Percentile is describe the relative standing of a value within a dataset. It helps you to understand where specific observations lies in relation to the rest of the data. Example, understanding the 50th percentiles. If X represents exam score and X 50th equals 25. So which means that 50% of students score less than or equal to 55 and another 50% score greater than or equal to 25. Therefore, the 50th percentile is the median of the dataset. Furthermore is measures of location, mean and median. which also called central tendency. The mean is the most common measure of the location of a set of the points. However, the mean is very sensitive to outlier because it uses every data value directly. If you change one number drastically, the mean can shift a lot. The median is the middle values when the data are ordered. So if is odd, it means that the median is in the middle number. But if even, we have to select the two middle numbers and divide it by 2, so we can see the medians. We also have measures of spread, which are rank and variance. It shows us how spread out of the data around the center. If all values are close to each other, the spread is small, but if values are far apart, the spread is large. And what is the definition of the rank? Rank is the difference between the max and min. So its formula is max subtracted by min. And it's very sensitive to outlier because it depends only on the extreme values, and the rank increases drastically. Next, let's move to variance. Variance is quantify how far values spread out around the mean. If all values are equal, it means that the variance is equal 0. But if a larger variance, it will be more variability. And visualization. Visualization is the process of converting of data like numbers and categories into visual formats like charts, graphs, maps, and tables, so that the characteristics of the data and the relationships among data items or attributes can be analyzed or reported. Visualization of data is one of the most powerful and appealing techniques for data exploration. Like humans have a well-developed ability to analyze large amounts of information that is represented virtually, which means that humans are inherently visual thinkers. Human brains are wired to detect shapes, colors, and patterns much faster than reading numbers or text. Here is the example of sea surface temperature. The following show the sea surface temperature for July 1982, which is a global visualization showing how warm or cold of the surface of the world's ocean were during that month, and each point on the map corresponding to a specific latitude and longitude. This is representation. Representation is the mapping of data object, their attributes, and their relationship to graphical features such as position, shape, color, and orientation. The goal is to choose representations that make the underlying data pattern visible and understandable. Example, objects are often represented as a point, and the attribute values can be represented as the position of the point or characteristic of the point. Example, color, size, and shape. And then let's move to arrangement. Arrangement refers to the placement or ordering of virtual elements within a visualization or display. In short, arrangement controls where things go and how they are organized in a virtual place. So why arrangement matters? The way you arrange data visually can make a huge difference in how quickly a viewer can understand the data and whether important patterns become visible or hidden. And this is the two images of examples. The left table image a random arrangement. You can see that the placement of zeros and ones seem random. It's difficult to see any clear patterns or structures. So you can easily tell whether there are a relationship among rows or columns. But in the right table, you can see that there are still the same rows and the same column, but we just reorder the data values. Another pattern emerged. Notice how ones are grouped together and how zeros are grouped together. It's easier to detect cluster correlations or group similarities. So both tables contain the same information, but the arrangement determines how understandable and interpretable the data is. Furthermore is selection. Selection is about eliminating or reuse emphasis on some data so that what remains is clear and easier to interpret. In other words, we can say that selection helps you to focus on what matters and hide what it doesn't. Selection may involve the choosing a subset of attributes, such as dimensionality. Reuse is often used to reduce the number of dimensions to 2 or 3, but they still keep much information as possible. Selection may also involve choosing a subset of objects, like regions of the screen can only show so many points and can simple but want to preserve points to a sparse areas. And then let's move to visualization techniques about histogram. Histogram usually show the distribute of value of a single variable, and the height of each bar indicates the number of objects, and shape of histogram depends on the number of bins. Like in this example, the graph in the left hand side, it has 10 bins, and in the right hand side it has 20 bins of petal width. For this one, it's about bug plots. It was invented by J. Tukey. It is another way of displaying the distribution of data. And this is the image of a bug plot. The 10 percentile at the bottom is minimum, and then it's 25 percentile, it means quanta 1. The 50 percentile, it means quarter 2 or median, and 25 percentile, which is quarter 3, and another 10 percentile, which is maximum. And the data that more than the maximum, we decide that it is an outlier. And this is another visualization techniques about scatter plot. Scatter plot is a type of visualization that displays the relationship between two or more numerical variables by plotting data points on a coordinate system. And the attributes can be displayed by using the size, shape, and color of the marker that represents the object. It is useful to have arrays of scatter plots that can compactly summarize the relationship of several pairs of attributes. This is another visualization is contour plot. Contour plot is really useful when a continuous attribute is measured on a spatial grid. The Catalan connect a point that have the same value of the measured attributes. So the closer the contour lines are to each other, the steeper the change. So the regions between lines are often filled with color gradient to make the transition easier to interpret visually. This page as well is about metric plots. It's a visualization technique that displays data in a grid or metric form, where rows and columns represent different objects or attributes. Metric plots, it can plot a data metric. This can be really useful when objects are sorted according to class. Typically, the attributes are normalized to prevent one attribute from dominating the plot. The plot of similarity or distance matrix can also be useful for visualizing the relationship between objects or two variables. This one as well is an example of Ayres correlation matrix. Each pixel in the matrix shows how similar or correlated between two samples that based on their features values. The dataset is grouped by species, which are Cytosa, versicolor, and virginica. The color bar on the right represents the correlation strength, the dark the dark red is very high correlation, yellow ones is moderate high correlation, and the blue one is low correlation. So the red color shows that the samples within each species are highly correlation, which means that the flowers of the same species have similar sepal and petal measurement. At the same time, gradient meaning that you can see the transition from a red within a species to blue or yellow between species. This shows clearly that the separability separability among the three array species based on their measure attribute. Next is visualization techniques about parallel coordinate. Parallel coordinate is really Parallel coordinate is used to plot the attribute value of high-dimensional data, since it is used to visualize multi-dimensional data that we can easily plot it using traditional 2D or 3D graph. Attribute value of each object are plotted as a point on its corresponding coordinate axis, and the points are connected by a line. Thus, each object is represented as line. So if you have 4 features, it means 4 parallel axes. If you have 100 samples, it has 100 lines. And this one as well is example of parallel coordinate. Each line is in the plot represents one flower from the arrays dataset. Both show the same arrays dataset but with different arrangement or scaling of axes. Like in the left plot, the axes are ordered simple length, simple width, petal length, and petal width. So you can see that the Cetosar, the blue one, is separated especially on the petal length and petal width. For versicolor and virginica overlap more but are still somewhat distant. So in the right plot, the axes are rearranged slightly different order. Example, sepal width, sepal length, petal length, and petal width. It's rescale. This reordering can change how lines across or appear. You can see better the relationship between sepal width and other feature. So some crossing between more apparent, useful for understand correlation between features. This is the other visualization techniques. Like star plot, it's similar approach to parallel coordinate, but axes radiate from central point, and the line connected the value of an object as a polygon shape. For Chernoff phase, it was invented by Hermann Chernoff. Each variable in the dataset mapped to a facial feature such as eye size, mouth shape, nose length, or face width. Each data point becomes a unique face. And here there's the example of star plot. For Cetosar, it's very small, narrow shape. This indicates that Cetosar flowers have small sepal and petal length and width. Their values are constantly low across features. As for versicolor, we can see that it's slightly larger, more balanced polygon. It suggests that medium-sized petals and sepal larger than Cetosa but smaller than Virginica. And for Virginica, it's the largest and more extended polygons. It indicates that a longer sepal and petal over larger flower dimension. And this is the example of Chernoff phase. First, you can see that Cetosa still has a small shape that almost expressionless face. It indicates low value for most measurement. And another one versicolor. The faces are more defined and it's slightly wider or can be taller. Another one is virginicar. You can see that the shape is larger than uh, versicolor and cytosar. Example that it has taller head and the eyes are larger. It indicates constantly that high measurement across the feature. Furthermore is OLAP, which is online analytical processing, first proposed by E.F. Code, the father of the relational database. And the relational database put data into tables, while OLAP uses a multi-dimensional array representation. And there are a number of data analysis and data exploration operations that are easier with such a data representation. And another one is data cube. Data cube is the core concept in OLAP as well. It's a multi-dimensional representation of data, where each dimension represents an attribute together with all possible aggregates. By all possible aggregates, we mean the aggregates that result by selecting a proper subset of dimensions and summing over remaining dimensions. Example, if we choose the species type dimension of the array's data and sum all over together dimensions, the result will be one-dimensional entry with 3 entries, each of which gives the number of flowers of each type. And another OLAP operation is slicing and dicing. Slicing is selecting a group of cells from entire multi-dimensional array by specifying a specific value for one or more dimension. Example, you're supposed to have a cell cube with dimensions. Time, it has year, quarter, and month. Product, it has category, item, and region, it has country and city. So if you slide the cube for year equal to 2024, you get a 2D table showing sales by product and region for 2024 only. And another one is dicing. It involves selecting a subset of cells by specifying a range of attribute value. For example, for the same cell cube, if you select year 2023 and to 2024 and the products, it has electronics and furniture. Therefore, the region is North Africa and Europe, so you can get a subcube of cell data restricted to those ranges. And this one, another OLAP operations, which are roll up and drill down. So roll-ups mean aggregating data by climbing up the hierarchy of a dimension. It's summarizing information at a higher level. For example, each date is broken down from year to month and week, and for locations from continent, country, state, and to city. This roll up, you can think it of as zooming out of the data. And for drill down, it's the opposite of rolling up. It increases data by moving down the hierarchy of a dimension to view final grains data. Example, time, it has year, quarter, months, and day. So drilling down from year to month show monthly breakdown of annual sales. So that's all for today's lessons. See you next time. Goodbye.